Today we'll talk about why Fukushima nuclear disaster was preventable. On the 11th of March 2011, the fourth largest earthquake in recorded history triggered a large tsunami, which will probably be remembered from the dramatic live pictures in a country which is possibly the most tsunami prepared in the world. The earthquake and tsunami caused a major nuclear disaster plant accident at the Fukushima Daiichi, owned by Tokyo Electric Power Company. The accident was likely more severe than the 1979 Three Mile Island and less severe than the Chernobyl 1986 accidents. Yet, after the 26th of December 2004 Indian Ocean tsunami had hit the Madras Atomic Power Station, there had been renewed interest in the resilience of nuclear power plants to tsunamis. The 11th of March 2011 tsunami hit the Onagawa Fukushima Daiichi, Fukushima Daini, and Tokai Daini nuclear power plants, all located approximately in a 230-kilometer stretch along the east coast of Honshu. The Onagawa nuclear power plant was the closest to the source and was hit by a tsunami with an approximate height of 13 meters, of the same height as the one that hit the Fukushima Daiichi. Even though the Onagawa site also subsided by 1 meter, the tsunami did not reach the main critical facilities. As the International Atomic Energy Agency put it, the Onagawa nuclear power plant survived the event remarkably undamaged. At Fukushima Daiichi, the 3 reactors in operation were shut down due to strong ground shaking. The earthquake damaged all off-site electric transmission facilities. Emergency diesel generators provided backup power and started cooling down the reactors. However, the tsunami flooded the facilities, damaging 12 of its 13 emergency diesel generators and caused a blackout. Among the consequences were hydrogen explosions that released radioactive material in the environment. The radioactive fallout was dispersed locally, regionally, and globally over land and sea by the weather. After the accident in Fukushima, areas to the northwest of the reactor plant received high levels of contamination, particularly in the prefecture of Fukushima. Outside of Japan, the level of contamination with radioactive material from the Fukushima reactors was low. Foodstuffs were contaminated by radioactive material that was deposited on the leaves or directly on agricultural produce such as fruit and vegetables, or that was absorbed via the roots of fruit and vegetable crops. As a result of the Fukushima accident, not only was the radioactive material released into the atmosphere, but it also entered the water, primarily the water that was fed into the reactors for emergency cooling, but also the groundwater penetrating into the reactor. Large quantities of contaminated water were pumped out of the reactor, cleaned of radioactivity by filtering, and stored in numerous tanks on the reactor site. Outside of Japan, worldwide measurements following the accident showed that contamination with radioactive substances from the Fukushima reactors was low, partly because 80% of the radioactive material was distributed into the atmosphere in the direction of the Pacific Ocean. This material was primarily dispersed in the northern hemisphere, where it became diluted. Still, minimal quantities of radioactive material reached as far as Germany. But why did it fail? It is unfortunately clear that Tokyo Electric Power Company and Japan's principal regulator, Nuclear and Industrial Safety Agency, had failed in providing a professional hazard analysis for the plant, even though their last assessment had taken place only months before the accident. The main reasons are the following. 1. Insufficient attention was paid to evidence of large tsunamis inundating the region. 2. The design safety conditions were different in Onagawa, Fukushima, and Tokai nuclear power plants. It is inconceivable to have different earthquake scenarios for the nuclear power plants at such close distance from each other. 3. Studying the substandard Tokyo Electric Power Company analysis performed only months before the accident shows that it is not the accuracy of numerical computations or the veracity of the computational model that doomed the nuclear power plant, but the lack of familiarity with the context of numerical predictions. Inundation projections, even if correct for one particular scenario, need to always be put in context or similar studies and events elsewhere. Or to put in better words, following a recipe from a great cookbook and having great cookware does not always result in great food if the cook is an amateur. The Fukushima accident was preventable had the plant's owner followed international best practices and standards, They would have predicted the possibility of the plant being struck by the size of the tsunami that materialized in 2011. If the emergency diesel generators had been relocated inland or higher, there would have been no loss of power. A clear chance to have reduced the impact of the tsunami at Fukushima was lost after the 2010 Chilean tsunami. Standards are not only needed for evaluating the vulnerability of nuclear power plants against tsunami attack, but also for evaluating the competence of modelers and evaluators. Officially, nobody died. In the case of Fukushima, although 40 to 50 people experienced physical injury or radiation burns at the nuclear facility, the number of direct deaths from the incident are quoted to be 0. In 2018, the Japanese government reported that one worker has since died from lung cancer as a result of exposure from the event. How many are projected to suffer in the long term from low-level radiation exposure? In its initial health risk assessment of the nuclear disaster, published in 2013, the World Health Organization noted exposure levels too low to affect human health for the national population, with exception to a few communities in the closest proximity. The follow-up WHO report published in 2015 suggests very low risk of increased cancer deaths in Japan. Did you know nobody really died in the Fukushima accident? Tell us your thoughts in the comments. Also, watch the videos that are on your screen because I'm sure that you'll love them, and I'll see you in the next video.